fitting functions to data. What we're going to do is we're going to look at, in the notes I have 4 XY tables. Do you see them? We're going to look at them and we are going to identify if they are exponential functions or if they are linear functions or if they are quadratic functions. I'm going to show you how to determine if it's one of those 3 things. If it doesn't fit my pattern for one of those 3 things, then it would be none of them. Now on your homework, you actually have 4 options. Is it exponential? E. L for linear. Q for quadratic. Or N for none of those. Okay? All right. Are you ready? Good answer. All right. So we're going to talk about these things called finite differences. What the heck is a finite difference? It sounds a lot more confusing than it actually is. All right? So what I'm going to do is I'm going to do something called the first order finite differences. What that means is I'm going to look at my y values. First off, I need to just make sure all the x values in order. Yes, on all of them. Yes, because I can't just have them in a random order. They have to be in a consecutive order. And now what I'm going to do is I'm going to look and see, how do you get from 1 to 4? Well, 1 to 4, you would add 3, right? And then my next one would be to get from 4 to 16, you add what? 12. And then from 16 to 64, you add what? Let's see, 64 minus 16, I add 48. And to get to 256, from 64, I add 192. So? That's my first order finite differences. I'm going to do that for all 3 of those and we're going to see what happens, okay? How do you get from 1 to 7? Add 6. How do you get from 7 to 13? Add 6. How do you get from 13 to 19? Add 6. How do you get from 19 to 25? Add 6. That one looks a little different than the one before it, doesn't it? Okay. Let's check down here. How do you get from 1 to 9? Add 8. By the way, you could potentially also subtract. If it said to get from 9 to 1, you would do minus 8 instead of plus 8. And that's totally fine as well. How do you get from 9 to 33? You add 24. How do you get from 33 to 73? You add 40. Is that right? How do you get from 73 to 129? You add 56. Okay. Not as interesting as the last one, but let's keep going. How do you get from 12 to 36? You add 24. How do you get from 36 to 108? Plus 72. How do you get from 108 to 324? You add 216. Now, one of these things is not like the other. Exactly. So which one's not like the others? The second one. Why? Because it's what we would say constant. The first order finite differences, which I just found for all 4 of these, is constant. As soon as you find the first order finite differences being constant, you have a linear function. That is when your first order finite differences are constant. And this is mathematically how you'd write that, but that's kind of confusing. So we have a linear function going on right there. In other words, if I were to graph it, what shape would it make? A line. Now, when we get to your homework and such, and on the test, what I'm going to want you to do is I'm going to want you to write the actual equation of that linear one. So how do we write a linear equation? Well, usually we see linear equations in y equals mx plus b form. Yes? Well, this right here that we found, this constant difference, guess what that is? That's our m value. That's your slope. So I know my equation is going to be y equals 6x and then something. How do I find b? When you graph a line, b is your y-intercept. What do you know about a y-intercept? You get a y-intercept when x is 0, right? So what's my y-intercept? My b value is 1. So that's the linear equation that describes this data right there. Questions about finding a linear relationship? No? All right, now we got to figure out what these other three are. They're either quadratic, exponential, or none of them. So, we just did the first order. Now let's do the second order. What does that mean? Well, let's go from 3 to 12. What do you have to do? Add 9, right? 3 plus 9 is 12. 12 plus what is 48? 36. And what about 48 plus what is 192? 144. Now there may be a pattern in those numbers, but it's not an obvious pattern like this. We're looking for constant numbers. So far not constant, right? Let's go down here. How do you get from 8 to 24? Add what? 16. How do you get from 24 to 40? Add 16. How do you get from 40 to 56? Add 16. Huh. Interesting. How do you get from 24 to 72? You add 48. How do you get from 72 to 216? You add 144. Once again, one of these things is not like the others. Which one? The one down here in the corner, right? This one, the first order finite differences were not constant, but the second order finite differences are constant. What does that tell me? Well, that tells me that I have a quadratic equation. The second order finite differences are constant. So what do I have here? Quadratic. Now, let's think about this for a minute. I want you to bring up some of the stuff that you learned about polynomials way back when. When first order differences are constant, you have a first degree equation. When second order finite differences are constant, you have a second degree. If you had third order, meaning you went out one more level, what degree would it be? Third. If you went out 4 times, it would be a fourth degree. And that's the case all the time with polynomials. Okay? So technically you can check for polynomials pretty easy just by continuing this cycle of finding the differences there. All right? Now, linear, we had to write an equation. Quadratic, we're not going to worry about writing an equation because it's actually a whole lot more involved than the linear one. So we're just going to not write an equation there. Are you okay with that? All right. So linear, we're done. Quadratic, we're done. Let's check for, let's see if I have another color that I could use. Maybe this one. Let's check for exponential. So I'm down to these two. They were not constant for the first order or the second order. Now, I don't want to go one more level out because that would show me if it was a third degree, right? And an exponential isn't a third degree equation. So even if I found out it was a third, well, it would kind of help me a little bit because it would tell me it's none of these. But exponential is not a polynomial like linear and quadratic are. So we have to completely try a different method for those. All right? So here's what I'm going to do for exponential. You ready? I'm going to take the second y value. What's the second y value? 4. And make a fraction with it over the first one. So I'm kind of working backwards. 4 over 1. I'm going to make another fraction. That's going to be the third one over the second one. I'm going to make another fraction. That's the fourth one over the third one. Do you see how I'm always taking a y value and making a fraction over the term in front of it? No. 64 over 16. 16 over 4. 4 over 1. What's my last one going to be? Over 64. Now, if this is exponential, then each one of those fractions will reduce to the same number. What does 4 over 1 reduce to? What does 16 over 4 reduce to? What does 64 over 16 reduce to? And I'm guessing that 256 over 64 also reduces to the same thing, and it does. So my constant happens with these fractions, not with those finite differences. That's what makes it exponential. Okay? Now, something that is very critical. You must do the fractions setting it up the way I did, where you're kind of going backwards and setting it up over the term in front of it. If you were to go the other way around and do 1 over 4, 4 over 16, 16 over 64, and 64 over 256, you would still get a constant, but what would that constant be? It would be 1/4, wouldn't it? And so you would still be able to conclude that it's exponential. The problem comes with writing the equation, because we didn't write quadratic, but we are going to write equations for exponentials. So here's our basic equation for an exponential. Y equals AB to the x. Usually you're going to end up putting parentheses around the b. Just happens. It's a lot easier to read it if you just put parentheses around the b. And here's why you want to put your fractions in the order I have. Because as long as I have it the way I did it, then guess what this 4 is? That's my b value. If I do it the other way, I have to flip it to get my b value. It's just a little more work. So always just go over the term above it, or over the term in front of it, I should say. So there's my b value. How do you think I find my a value? Same exact way I found this over here. I'm going to go find where is x 0, and then my y value is actually my a value for my equation. So what's my equation here? I know this is exponential. And what's my equation going to be? Y equals a, which is 1, times b, which is 4, to the x. Do I technically need to write the 1? I don't have to, but since I did, it's fine also. Not too bad? Okay, let's check the last one that we haven't qualified yet. We know it's not linear because it wasn't constant here. We know it's not quadratic because it wasn't constant here. So let's check for exponential. How do I set up my first fraction for exponential? I take the second y value and put it over what? 12. And then I'm going to take 108 and put it over 36. And then 324 and put it over 108. And let's see how these reduce. 36 over 12, I know that reduces to 3. What about 108 divided by 36? Also 3. And 324 divided by 108? Also 3. So since I have something constant here, what kind of function do I have? Exponential. Now, since it's exponential, do I need to write an equation? Yes. What's the only one I don't need to write an equation for? Quadratic. Exponential I need to. So I know my b value is what? 3. What's my a value? Not 12. I need to know what happens when x is 0. So in other words, if I put an x value of 0, wouldn't that technically be what comes right before this one? So let's try and use that pattern. So let's see. If I were to think backwards from this, 12 times what is 36? 3. 36 times what is 108? 3. So they're multiplying by 3 each time, aren't they? So what number, when you multiply it by 3, would give you 12? So the original point there would have been 0, 4. So what's my a value? 4. So what's my equation then? Y equals 4 times 3 to the x. Questions there? Okay, on your homework, you have several of them. You have to identify what type it is and then fill in the equation. Now, if you identify that it's none of these, there is no equation to fill in. If you identify that it's quadratic, there is no equation to fill in. You're only filling in the equation for exponential and linear. If you look at the charts, they're all fine. Hopefully your copy is a little bit better than this one. But number 5 is missing that first y value. Do you see that? That's just like the problem I just did. So you're going to have to look at the rest of the chart and come up with the pattern and then think backwards using that pattern to figure out what goes in that blank. It looks funny. It looks like it was a mistake because it's the only one that's like that, but it actually was intentional. Okay, so just be aware of that as you're going. Any questions? All right, happy studying.